Okay, the next section is 9.1. We're going to look at some basic combinations. So you're going to learn about discrete versus continuous briefly, and the importance of counting. In fact, you can read more about these in the book, but this whole chapter is on discrete math, which is math that we can count up finite number of things, versus obviously continuous, an infinite number of things. The importance of counting the book also talks about. So if we talk about the probability of an event happening, we need to also look at the probability the event happens randomly on its own. So that's kind of what we're looking at today, the probability that an event happens randomly. All right, we'll also look at the multiplication counting principle, permutations, combinations, and subsets. All right, let's slow down and look at an example in detail then. Let's say that we're going to pick 3-letter codes from 4 letters. So we want to write out all these possible scenarios. You might want to start with a systematic way, like start with A and then choose, 2 other letters. So then start with A again and then choose, okay, maybe B, then D. And keep going with this process. Maybe now C, D. And what you're going to find is that there are 24 total ways to write all this out. So here's all the ways right here. There are other ways to look at this. You could look at it in terms of a tree diagram because you have a choice for the first letter. And for the first choice, you have 4 different choices here. So you can pick the letter A first, B, C, or D. For the second choice now, you can't pick letter A, so now you only have 3 choices. And for the last choice, now you only have 2 letters left over for your final choice. So the tree diagram here is also a really good way to represent it. So then that brings us to the multiplication principle of counting, which is going to be sort of the most basic way we add things up in this chapter. It says if a procedure P has a sequence of stages, S1, S2, and so on, S1 can occur in R ways, S2 can occur in R2 ways, then basically what you do is you just multiply those number of ways together. So if you go back to this example right here, we had 4 choices for the first letter, we had 3 choices for the second letter, and we had then 2 choices for the third letter. So what it's saying is we just need to multiply these together. 4 times 3 is 12, times 2 is 24, and that gives us 24 total ways that we can arrange these 3 letters from 4, which is, you multiply the branches of this tree diagram basically. So let's try it again for another example. This one says a license plate has 4 letters followed by 3 numbers. So we got 4 letters first, and then we've got 3 numbers. Okay, so for the letters, there's 26 letters. So we have, if you look at a tree diagram for this one, you'd have 20, which I'm not going to draw this all out, obviously, but you could pick A, you could pick B, you could pick C, you could pick D, and there's 26 total possibilities. Now, if you're going to pick another letter after that, you also have another 26 options, A, B, C, and so on. So you'd have 26 for the second letter, and you'd have 26 for the third, 26 for the fourth. The numbers then, these are numerical digits 0 to 9, so there's 10 options for each of these. So we would just multiply the branches. There's 26 in this branch, there's 26 in this branch. The multiplication counting principle says that we multiply these branches basically. So if you multiply this all out, you get about 456,976,000, which, could account for everyone in the state, for example. Okay, let's look at permutations then. The book says they're n factorial permutations of an n set, so let's look at an example of that. Let's say we want to choose an 8-letter word. We've got 8 letters to deal with here, and we want to know how many words can be formed. Now, these aren't actually words in the dictionary, just how many combinations of these letters can we make, basically. Well, for the first choice for the letter, we have 8 options. We can choose any one of these letters. For the second choice, we have 7 letters to choose from, and then obviously 6, 5, and right on down, so it's 8 factorial, or 40,320. And I will show you how to do this in the homework help on your calculator. And also we'll do distinguishable permutations where we have letters that repeat and how we handle that. I'll just give you the formula for now for distinguishable permutations though. We do the n factorial, but we have to divide out the things that are the same. So the letters that are the same, you divide those out. So if there's an O that repeats 3 times in the combination of letters, for example, we have to divide out 3 factorial to represent those 3 O's. Okay, next are permutations and combinations. Permutation, there's a formula for permutation. The number of permutations n objects taken r at a time. Sometimes we're going to write it like this. And this is the formula that we would actually use to solve it. I did put that on your formula sheet. What's important is that you know that order matters for permutation. Do an example in a second. Order does matter for permutations. So then combinations is right here. It's got a larger denominator, you'll notice, because it's got the same thing in the denominator we had for permutations, but plus an r factorial. And this is where order doesn't matter. That's really important. And you can keep it straight from the formula as well, because if the denominator is bigger in this one, there's fewer options, which makes sense because if order doesn't matter, there's fewer ways that you can make something happen. If order does matter, if you're arranging these 4 letters and order matters, then there's going to be a higher number of ways that you can arrange them. Or picking. If you're picking, let's say you're picking 4 letters, and order does matter, then there's going to be a larger number of ways you can rearrange them. So here's an example. How many 10-person committees can be formed from a group of 20 people? So we need to choose whether we're going to use permutations or combinations. We're choosing 10 from 20, so it's either 20 P10 or 20 C10. And we're going to use 20 C10 because order doesn't matter here. We're choosing 10 people. It doesn't say that we need to choose them in a specific order. It doesn't give us any other information. So order doesn't matter in this case. So we're going to use 20 C10, which we can do in the calculator just by hitting 20 and then going to math, scrolling over to probability, scroll this way, and then scroll down to NCR and hitting 10. You enter there, it gives you 184,756 total committees, total ways to do the committee. All right, let's try the homework and hopefully we can make sense of this.